The software employs an iterative procedure to solve for the unknown parameters, and there are 5 major unknown parameters that the software is solving for, and that is the water outlet temperature, the air dry bulb outlet temperature, the airflow rate through the cooling tower, the pressure at 0.5 based on the dimension sheet, and the pressure at 0.6 based on the dimension sheet. For these design parameters, you have to supply solution tolerances. Because the software is using an iterative scheme, it needs to know when it needs to stop with the solution. And it will stop with the solution when, from the one iteration to the next, that the water outlet temperature will be less than 0.01 degrees centigrade. The same with the air outlet temperature, with the mean airflow rate between 0.1 and 0.5. The tolerance level is 1, so if it's less than 1 kilogram per second, it will meet that tolerance level. And for the other 2 pressures, it is 1 Pascal from the one iteration to the next. If you are not happy with the results at the output, you can obviously change these tolerance levels. The software also needs initial conditions for these 5 design parameters. You can either select calculate for the initial condition selection. If you select calculate, these fields will not be active, and the software will calculate those conditions for you or estimate those conditions. If you want to specify them explicitly, hit specify. The input fields become active and you can enter those values here. If you've run the solution already, you can also use the current solution as the initial solution. So if you're doing a lot of analysis with playing around with different inputs, it might be a lot quicker to get to the final solution if you use the previous solution as the new initial solution. If we click it here, you'll see a warning message because there's no current solution. So because we haven't run the software yet, there's nothing to put in there. Since the solution process is prone to numerical instabilities, it is necessary to slow down the iteration process from the one iteration to the next. And we've introduced relaxation parameters. Now what this means is, for every iteration, when we've calculated a new value of the water outlet temperature, air outlet temperature, the pressures, or the mean air flow rate, it slows down the iteration process. So if we've calculated a new value of the water outlet temperature, in this case, it will only change that value by 20% and not the full value. And that is to slow down the iteration process. And we'll explain when we solve for a cooling tower, we'll select different relaxation parameters, but we highly recommend that you use values of 30% or 0.3 or lower. And you'll see if you select a value here that's too high, although it will speed up conversions, it will lead to numerical instability and the solution process will fail. So generally you wouldn't need to play around with these parameters, but there might be instances where it is necessary to make them smaller, or if you want to speed up the process, you can make the values larger. One also needs to specify the maximum number of allowable iterations. If the solution algorithm reaches 200 or whatever number you specify here, it will stop execution and it will take you to the outputs. It will also warn you if the maximum iterations was reached. The maximum iterations are just there to prevent the software from running a very long time if it fails to find a solution. One can also stop the execution of the software manually by clicking the stop button. If it reaches the end of the current iteration, it will stop execution and it will just give you a text message here to tell you that the execution stopped successfully, and then you can go to the output and look at the output, because sometimes it did converge. If your solution tolerances are too small, it might run a long time still, but if you visually see that it did converge, you can stop it and you can look at the outputs. The input fields that you see here is a function of the tower that you want to solve. The input fields here are for a mechanical draft cooling tower. If we select a natural draft cooling tower and we click on persist tower type choice, we click on that. If we go back to control, we just give it a second, it's making all the changes, and you can see there's a draft equation box that appear here, and we'll explain that at a later stage when we solve for a natural draft cooling tower. If we change the tower type to cross flow cooling tower and we say persist choice, if we go to the control tab, this will disappear again. We'll just give it a sec or two. You see that disappears because it's not applicable to cross flow cooling towers, and there's a new cross flow control parameters input field that pops up that you need to use.